Electrolysis of molten sodium chloride. This is today's lesson. First of all, let's try to learn about molten sodium chloride. Sodium chloride, which is solid at normal state, at normal temperature. When this sodium chloride is heated at 801 degrees Celsius, then solid sodium chloride turns into liquid sodium chloride. Actually, liquid sodium chloride remains as ions, sodium ion and chloride ion. This is about molten sodium chloride. In molten sodium chloride, sodium and chlorine remain as ions, sodium ion and chloride ion. Now let's see electrolysis of molten sodium chloride in detail. Let us take glass wire or ceramic wire as electrolytic cell vessel. And in this vessel, molten sodium chloride, that is liquid sodium chloride, is taken. It remains as sodium ion and chloride ion. Now, two metallic bars or graphite sticks are submerged in the vessel. Now, these two metallic bars are connected to a cell power. Long bar indicates positive end of the cell. Short bar indicates a negative end of the cell. This is connected to negative end of the cell. That is why this is negatively charged, and this electrode is connected to positive end of the cell. That is why this is positively charged. We know this is cathode and this is anode. Negatively charged bar is cathode and positively charged electrode is anode. As this is negatively charged bar, that is why positively charged ion will move here and reaction will happen at cathode. Reaction at cathode. Sodium, which is electronically deficient, this is electronically rich. That is why sodium ion will receive electron from this cathode and sodium metal will be formed. This sodium metal will deposit on the surface of the cathode. It's a kind of reduction reaction. We know the metallic bar where reduction happens, that is called cathode. So at cathode, sodium metal deposits. Now let's see what reaction happens at anode. Reaction at anode. Anode is positively charged and chloride ion is negatively charged. That is why chloride ion will move towards anode. Chloride ion, which is electronically rich and anode is electronically deficient. So chloride ion will donate electron to form chlorine atom. We know there is no existence of chlorine atom in the nature. Another chloride ion will move to anode and will donate electron to form another chlorine atom. These two chlorine atoms combine with each other to form chlorine gas. These reactions happen at the anode. That is, at anode, chlorine gas is formed. That is why gas bubbles are observed around anode. So, this is about electrolysis of molten sodium chloride. Simply, sodium chloride molten when electricity is passed through it, then sodium and chlorine are produced. Here, these gas bubbles are chlorine gas. How can it be detected? This is another point. If the arrangement is different type, so that chlorine gas is collected easily, then this chlorine gas is taken to a test tube, chlorine gas, and at the mouth of this test tube, wet blue litmus paper. Wet blue litmus paper is held. When this chlorine gas reaches the wet blue litmus paper, then it turns into red. The reason is that chlorine wet, that means water is here, reacts with water, and as a result hydrochloric acid and hypochlorous acid are formed. Because of the formation of acid, blue litmus paper turns into red. It is known that blue litmus paper turns into red in acidic medium. That is why here blue litmus paper turns into red. This is the way chlorine gas produced in these electrolytic cell can be detected. This is all about electrolysis of molten sodium chloride. Thank you very much.